What's up? What's up? It's your man Jimmy Chan. All right, so we're now talking about areas and circumference. Well, what area is the space that's taken up based on the shape itself. So if it was a parallelogram, the area would be how much it takes to cover this area. Okay, like carpet, flooring, and stuff like that, right? So if it's any of these shapes here, the parallelogram, rhombus, rectangle, even the square, it really is just the base times the height. The height and the base are always perpendicular to each other, okay? So it's always going to be perpendicular to each other. The base is perpendicular. The height and the base is perpendicular to each other, all right? However, the thing that we know about a square is that all four sides are the same. So you could call the base S, and which the bases can be S, the height can be S as well. So what you would have here would be S times S, which would give you S squared, okay? So if you want to remember extra, feel free to remember that A is equal to S squared. Other than that, area of a parallelogram, rhombus, rectangle, or square is really just the base times the height. Now, trapezoid is kind of like the cross between a triangle and a square, or I should say a triangle and a rectangle, right? So a trapezoid came about, so it's kind of like a combination of triangles and rectangles. So what you have here is that you still have areas equal to 1/2 the base times the height, but the base, there's two bases. One's the base up top, and the other one's the base on the bottom. I should say that better. The bases in this case are the two parallel sides, okay? Because if this was standing, right? So you could have a trapezoid that maybe looks something like this. Then the A and B would be these two sides here that are parallel to each other, right? Then I have those two, and then I gotta multiply by this height here, okay? So basically I gotta make sure I turn it around, okay? So again, the A and B are actually parallel to each other. So I should probably write it right here that A is parallel to B. Whoa, that's not what I wanted, but it's okay. Let's make it longer. There we go. So let me redraw B here. I never like my B's, do I? Okay, there you go. A is parallel to B, okay? Triangle is equal to 1/2 base times height. For a circle, it is pi r squared. Don't forget that the radius is also half of the diameter. So you could say that the diameter is twice the radius, right? Because the radius is really from the middle of the circle to the edge of the circle. And the diameter goes from edge to edge going through. So going through the center. So this right here would be your so-called diameter. So that would be your diameter, okay? So going through the center, side, all right? And the radius is basically half of that, all right? And then for the circumference, so we've talked about the perimeter of a shape or a polygon, and that is where we add up all the sides. But now that we're introducing circles, the perimeter of that has a special name, and that is circumference. Circumference is the distance around a circle. So again, you can say it's C is equal to pi d pi times the diameter, or since the diameter is equal to 2 times the radius, you can also call it c is equal to 2 pi r. All right, so let's take all of these formulas here that we are either going to be given or we're going to need to remember and apply it to this particular problem right here. Now, if you look at this problem right here, we actually have two things here, right? We have one really a big triangle right here, right? Let me go ahead and get that nice and centered. And then we have, a rectangle right there, okay? There we go, excellent. So the total area of this figure, right? So area, the total area is going to equal to the area of that triangle right, plus the area of that rectangle. Okay, so that's what we need to figure out, right? Well, the area is equal to the area of the triangle is going to be 1/2 base times height, while the area of the rectangle is just its base times its height. All right, so let's explore the base and height for the triangle. Okay, so if you look at the triangle, so again, we're just looking at just this piece here, right? So what's the base? Well, the base of this triangle isn't that all the way across, right? Now, is it wrong for you if you said, I see two triangles, and you want to add the area of each of those triangles, and then add the area of the rectangle to get the total area? You're welcome to do that as well, all right? So there's many ways of solving for this. In this case, I'm going to take this triangle as one big thing. So the base is right here, which would be 10 feet plus the 10 feet to give me the 20 feet, and the height is going to be 6 feet. So let's go ahead and go back in here. So this is going to be 1/2 times the base, which was 20, times the height, which is 6. And then the base and the height of that rectangle, right? So since this is 20, what do I know about the opposite side of a rectangle? They're equal. So this must be 20 either, as well. And this is 9 feet. So the base is going to be 20 and the height's going to be 9. So this would be 20 times 9. So there I go. So the area of the red is 1/2 of 20, which is 10, times 6, which is 60, plus 20 times 9 is 180. So therefore, my total area is equal to 240. 240 what? Well, since these labels here are feet, I have feet times feet. So I have feet squared, or square foot. So I got 240 square feet here. Well, I hope this helps. If you have any questions, let me know. Talk to you later. See ya. Bye.